operations.
Hello everyone, this is Socrates Kardakis, an MLOps specialist for AWS covering the largest MLOps engagements across EMEA. I decided to create a series of videos and share my experience in order to help you building your own MLOps platform. In this first video, what we will see is the definition of MLOps and why MLOps is important for us. Then we will cover the maturity journey that you need to follow in order to create an MLOps platform. And finally, I will show you a theoretical example from a customer on the journey that you need to follow. But let's crack on. Machine learning code that the data scientists use to produce is a very tiny piece from a bigger picture whenever we want to productionize this. This is a very old picture from 2015. However, it is still valid. We need to create many different configuration mechanisms, automations, data ingestion mechanisms, monitoring mechanisms around this in order to make sure whatever we move into production, it is secure and robust. The key challenges that our customers used to have initially is that they have so many different people like data scientists, ML engineers, data engineers, business stakeholders. They follow completely different KPIs and processes, and they need to use completely different services. So the key question that we have is how can we combine people, process, and technologies in order to productionize machine learning solutions efficiently? And actually, this is the definition of MLOps. MLOps is a combination of people, process, and technologies to productionize machine learning solutions efficiently. MLOps is a very difficult topic. Why? Because it requires a combination of multiple domains. For example, we need to combine machine learning with DevOps and data engineering together. But why MLOps is really important for you? Let's start with the key KPIs that we set with our customers. The first main KPI is to be more efficient. That means we need to improve the time to value. We have seen customers that they spend 12 months in order to productionize a solution from idea to production. We will show you how you can do that in less than 3 months. That means 4 times better speed to value. The second KPI we set is, let's say that we already have some ML use cases. We have implemented the research phase and we are ready to productionize. How long does it take to move an already existing ML use case into production? Normally, this takes 3 to 6 months to the customers. We will show you how you can do that in less than 2 weeks by, of course, reusing many components. In order to reuse the different components, the next KPI is about templatization. You need somehow to ensure that you reuse as much as possible of your code that you have created. Why is that? Because most of the different Lego blocks that data scientists or ML engineers they need to use, they're exactly the same among multiple ML use cases. The next one is we need to make sure that we are able to onboard new teams in order to start productionizing solutions. For some customers, this takes very long time. Why is that? Because they rely to other business units in order to create new environments, new accounts, to assign users, etc. So our goal is to templatize the whole infrastructure, use infrastructure as code, and then onboard new teams easily. The next KPI, and the most important for many customers, is to be secure. That means that we want to work in our own private cloud. We don't want our data to leak to the internet or to move across the web. And lastly, the last KPI that we set. On AWS, we have multiple services, multiple managed services that allows you to consume hardware only whenever it is necessary. Most of the customers, they used to have big servers or big clusters up and running all the time and consume hardware and consume energy consequently. That means that they increase the CO2 emissions. So we will show you how you will move to the world of serverless and to consume only the energy that is required for your ML use cases. But overall, the goal that we have is to reduce the cost in terms of people, processes, and technology, of course. But let's see the maturity that you need to follow in order to achieve this. We have created this maturity model in order to help customers to set checkpoints, digest the solution, help their employees to adapt to the new way of working, and then move on. In this maturity model, we have 4 key phases. The first phase is the initial phase. In the initial phase, we help the customers to understand how they can operate on the cloud, how they can use all the different machine learning services by AWS, and more or less we have the data scientists that they need to understand how to write their notebooks on the cloud and how to leverage all the different components like training, hyperparameter optimization, model deployment, or even processing. After we have the data scientists familiarize themselves on how to create the solutions and they have increased, let's say, the efficiency in terms of creating POCs, the next step is to move from the world of notebooks to the world of automation. In the world of automation, what we used to do is to move the solutions from the notebooks to repositories with a specific structure in order to create automatic workflows. These automatic workflows is what we call them ML pipelines. These ML pipelines are responsible to pre-processing, training, post-processing, and to move the models into a centralized place that later on we can productionize. So the key goal of this stage, of the repeatable stage, is to standardize the code into the repository, automate the way that we build these ML pipelines, and then centralize the place that we store our models. The next phase is the reliable phase. Now we know how to automatically create models or train models. The next step is to make sure that these models perform well and they move to production with a very robust way. In that case, we introduce multiple environments for our customers like development, testing, or production environment. Each environment has its own purpose. For example, the development environment is for building models and creating the automation. The testing environment is to test the end-to-end solution, and the production environment is responsible to serve the models to other applications. Over there, our goal is to standardize the different testing techniques, monitoring techniques, and of course to work only with CI/CD pipelines across all these multiple environments. Next phase. Next phase is the scalable phase. In the scalable phase, now what we have done is we have productionized one of the ML use cases. One team is aware how to use the whole platform and they start productionizing more and more ML use cases. How can we onboard multiple teams? We need to create a separate environment for a new team in order to start productionizing their solutions. How we can templatize the code and the infrastructure for these new environments. This is one of the key tasks. And also, at this level, we start templatizing the most common ML use cases. For example, you might have customers that they use standard ML or classic ML solutions in order to build their use cases. In that case, the most important thing is to templatize the solution and to reuse that everywhere. But let's simplify this diagram a little bit. We have initial, repeatable, reliable, and scalable phase. Initial phase, we standardize experimentation. Repeatable phase, we standardize the automation. Reliable phase, we standardize the guardrails, automation of tests and monitoring. And lastly, scalable phase is the templatization that we want to achieve. But let's see a customer journey and what are the benefits that we are getting out of this. We have different customers that they used to have thousands of models that they want to productionize, hundreds of data scientists that they need to collaborate, and terabytes of data. And most of the times, when we arrive to the customers, they complain that they don't know how to combine people, process, and technologies, and as we saw already. For example, the people, they lack of skills, right? And they don't know how to work with the different tools. They follow many manual operations and processes that is a very big overhead for them. And lastly, they use outdated technologies or tools that they cannot fully leverage, let's say, the cloud benefits. And what they ask most of the times is that they want to standardize the MLOps platform across all the different teams. They want to simplify the processes and to automate them, of course. And they want to make the people thinking how they need to operate on the cloud and to, let's say, change the way that they have used to work on premise. The end goal is to have faster time to value. How can we achieve this? The first thing that we do with our customers is to suggest all the native services and the managed services provided by AWS. These managed services are most of the times around Amazon SageMaker. For example, to create the different pipelines, as we can see here, we need to create Amazon SageMaker pipelines. Then for explainability and bias report, what we are using is SageMaker Clarify and model monitoring to monitor the different models. Then SageMaker has released the different Amazon SageMaker processors that helps you to run either Spark or Python, depending on your use cases. And of course, one of the key components for productionizing everything is SageMaker model registry. This is the place that we store all the different models. Then one of the key components that we use into MLOps is about SageMaker projects. SageMaker projects help you to templatize the whole the ML use cases and to ensure reusability. Then the next step is about auditability. How can we achieve auditability with AWS and Amazon SageMaker? We have Amazon SageMaker experiments, model registry that we can see all the different metadata of the models, and we have some really important components like model dashboard and model cards that covers all the different aspects of models, alerting, and monitoring. Then we need a place all the data scientists to work together, and this place is SageMaker Studio. SageMaker Studio is the IDE that they used to use in order to develop all the solutions either in research or using MLOps capabilities. And finally, all the services that we saw is, let's say, they are managed services and we are help us. And finally, all the services that we saw so far, they help us to improve sustainability. Why? Because these are managed services, serverless services, and we consume only the energy that is required for our ML use cases. By following this advice, we have seen customers that they are moving from initial to scalable phase. And most of the times, instead of taking 9 to 12 months to productionize something, now they spend 3 months instead of 3 to 6 months to move an existing solution to production. Now it takes around 2 weeks. And for many customers, they used to spend days and days to create new environments for new business units, for new data science teams. And instead of spending more than a month, now they spend less than 2 hours. But let's see how we track the success of such an environment. The first thing that we care about is how much time it takes in order to instantiate a new MLOps environment for a new team. Here you can see an example of a theoretical customer that we move from 40 days down to 1 hour. As you can see in this diagram, we talk about 12-month period. Of course, along the time, we are able to improve continuously the whole process. And based on the experience that we have, in order to build an MLOps platform on AWS, it takes 3 to 6 months, depending on the security measures that you want to introduce. The second diagram that we used to create is how many teams we have onboarded on AWS. This is very, very important because this shows if our platform has been adopted successfully by our employees. As you can see here, we have initially just one team while we build the MLOps platform, and gradually it increases. And when we start having just few hours to create a new environment, this will start increases exponentially. Next step is to track how many use cases, ML use cases, we have per development stage. For example, in this diagram, we're able to see what is happening across 12 months. The blue line here, the blue line is about all the ML use cases in the development stage. The green line is about all the different use cases into the testing stage, and the purple line is about all the ML use cases into production. As you can see, initially we start gradually increasing, linearly increasing the development of new solutions, and after that exponentially increase the number of use cases that we have in different phases. But let's see the key checkpoints across these diagrams. First one, this is the time that we created our MLOps platform. As you can see, before that we had many problems to onboard new teams, and after that we start seeing more and more people using our platform. The next important checkpoint is templatizing the infrastructure over there. As you can see, at this stage, we have achieved to fully templatize, fully automate the infrastructure code and the deployment and the automation of creating the MLOps platform. And we can do that now in less than 1 hour. And the last important checkpoint. The last important checkpoint is about ML use cases. After this particular point here, of the 5.5 months, what we achieved was to templatize the most common ML use case. And as you can see, at this stage, we had a linear increase of the development, and this is the reason that we exponentially start increasing the development of new solutions. So templatization of the most common use cases are really important. Okay, this is all that we covered in our first video. As a recap, what we saw is what is MLOps, why MLOps, the maturity model, and a customer example. Next time, we will continue with people and processes. Thank you for listening.